students, what you observed in these figures? All these are the three-dimensional shapes, but in all these we are observing that the shapes which are shown here are uh, not made by a single 3D shapes. They are the combination of 3D shapes. So all these figures are the solids are the combination of more than one 3D shape or 3D figure. So let us start the chapter number 13, surface area and volume, where we are going to study about the areas and volumes of the combination of 3D shapes. So let us begin with this. Before starting this, some points we have to revise that are very important for us: the different areas and the volumes of the three-dimensional shapes. So cuboid, its lateral surface is 2 into L plus B into H. Total surface area is 2 into LB plus BH plus HL, and its volume is L into B into H. Cube, its lateral surface area is 4A square. Total surface area is 6A square. Volume is A cube. Cylinder, as we know that the circles, when we stacked in a linear manner, or we can say we stack the circle 1 over 1, so we get a shape which is known as the cylinder. Observe, this cylinder is made by the curves, not the line segments, so it is known as the basic curved geometric shape. And in this sense, as this is not made by the line segments, its area is considered as curved surface area. So curved surface area of cylinder is 2 pi r h. Its total surface area is 2 pi r plus h, and its volume is pi r square h. Similarly, the cone is also a basic geometric curved shape or basic geometric curved shape. So its curved surface area is pi r l, and its total surface area is pi r plus l, and its volume is 1/3 of the volume of cylinder, that is 1 upon 3 pi r square h. Now sphere, its total surface is considered as curved surface, or we can say its surface area is 4 pi r square, and its volume is 4 upon 3 pi r cube. And the hemisphere, which is the half of the sphere, so its curved surface is 2 pi r square, and total surface area is 3 pi r square, whereas its volume is half of sphere, that is 2 by 3 pi r cube. Now these all the formulas we have to remember, which will helpful for the finding area and volume of the combination of solids. So let's start the problem. First question says two cubes each of volume 64 cm cube are joined end to end. Find the surface area of resulting cuboid. Here a cube is given. As we know that in the cube, length, breadth and height are same. So when one more cube is joined with this cube, we get a combined figure, that is the cuboid. Now here we get length, breadth and height in a cube are same, but in this combined figure we get the length is more, that is x plus x, 2x. So here in this we get the side of the cube is x, so length, breadth and height are same, but when the two cubes are joined, so we have the length is 2x, breadth and height are same, x. Now total volume of these two cubes, here it is 2 into 64, 128 centimeter cube. Now as we know that volume of cube is x cube, so we have given x cube is equals to 64, and we can say x cube is equals to 4 cube, or x is equals to 4 centimeter. Here we get the side of cube is 4 centimeter. Now what we have to find? We have to find the surface area of this resulting cuboid. As we know that now length, that is 4 centimeter, breadth, this is also 4 centimeter, as in this two cubes are joined, so length is x becomes combined figure 2 into x, that is 2 into 4 is 8 centimeter. So only length is changed but height and breadth are the same as 4 centimeter. So we have to find the surface area. So surface area, that is the total surface area. By combining these two shapes, we get the total surface area of the cuboid is twice of LB plus BH plus HL. Here 2 into, put the values of L, B and H, we get 2 into 8 into 4 plus 4 into 4 plus 4 into 8. After further solving it, we get the 160 centimeter square is the total surface area of the resulting cube. Now let us consider the third problem of the exercise. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is given 15.5 centimeter. Find the total surface area of the toy. Now here this figure is combination of cone as well as the hemisphere. So what we have to find? We have to find the total surface area, that is boundary of this hemisphere and the surface area, lateral surface area, or we can say curved surface area of this cone. So first of all, the radius of the both shapes, cone and the hemisphere, are same, given 3.5 centimeters. So here this one is the cone where its radius is 3.5 centimeter. So total height of the cone is total height of the toy is given 15.5 centimeter. So what we can find out here, the height of the conical part of this toy, that is, as in the hemisphere we know that this radius is the height. So from 15.5 we subtract this radius 3.5, so we get the height of the conical part of this toy is 12 centimeter. So we can say height of the cone is 12 centimeter. Now the curved surface area of the conical part of this toy is, we know that pi r L. Now here L is known as the slant height. So first of all we have to find out the slant height, as we know that the slant height L square is equals to H square plus R square. Now put the values of R is 3.5 and height is 12 centimeter. We get L square is 12 square plus 3.5 square, or it is equals to 144 plus 12.525 becomes 156.25 centimeter. So by squaring it we get slant height L is 12.5 centimeter. Now we can find out the lateral surface area, or we can say curved surface area, pi r L. Similarly, this down part of this toy is in the shape of a hemisphere. So we have to find the CSA of hemisphere. Now as we know that CSA of hemisphere is 2 pi r square, and here again the radius is 3.5 centimeters. So total surface area of this toy becomes sum of curved surface area of this cone and the curved surface area of hemisphere, that is pi r L plus 2 pi r square. Now here in these two terms we have pi and r is common, so take it out common, pi r. So rest of the quantities we get L plus 2r. Now put the values, we get 22 by 7 into 3.5 into 12.5 plus twice of 3.5. So this 3.5 we consider is 35 upon 10 by removing the decimal of this, and 12.5 plus 2 into 3.5 becomes 19.5. Now we can simplify it. So how it is simplified? 7 5s are, and this 2 5s are 10, 2 11s are 22, and this 5 and this 5 again cancel out. We get 11 into 19.5 centimeters square, or product of these two terms is 214.5 centimeters square. So here we get The total surface area of this toy, which is the combination of cone and hemisphere, is 214.5 centimeters square. Now let's take one more problem of this exercise, question number 4, which says a cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. Now here, as in the figure, we observe that the cubical part or cubical block is there, and on the cubical top there is a hemisphere on this top. So the diameter which can be considered for this hemisphere is the breadth of this cubical block, and breadth of this cubical box is 7 centimeters. So we have the diameter of this hemispherical shape is 7 centimeter. Now the greatest diameter of this hemisphere is 7 centimeter. So diameter is 7 centimeters, so we can say the radius is 7 by 2 centimeters. Now the surface area of this solid, which is the combination of cube and the hemisphere on the top, it is total surface area of cubical box plus surface area of hemisphere, this one, minus base area of this hemisphere, as the base area of this hemisphere is not considered. So we can say total surface area of cubical box is 6a square plus 2 pi r square minus pi r square, as we don't have to find the total surface, we have to find the curved surface. Curved surface is 2 pi r square, but this base of this hemisphere is also a circle. This area we are not considering here, so we have to subtract this pi r square from this sum of the total surface area of cubical box and surface area of hemisphere. So it is becomes, by putting the value of side of cube, r and pi, we get 6 into 7 square plus 2 into 22 by 7 into 7 by 2 into 7 by 2 minus 22 into 22 by 7 into 7 by 2 into 7 by 2. Here we cancel out these two terms, 7 and 7. This 2 cut divided by this, we get 11. Now here again, here also this 7 and 7 will cancel out. This 2 divides this 2 one time, and this 2 divides 22 11 times. So here in the next step we get 6 into 49, as 7 square is 49, plus this 11 into 7 minus 11 into 7 by 2. Here 294 plus 77 minus 7 by 2. After solving this, we get 332.5 centimeters square, as we take the LCM and solve it further. So we can say here the largest diameter of this hemisphere is 7 centimeter, and the total surface area of the solid is 332.5 centimeters square. So remember one thing, whenever we have to find the area and surface area of the given solid, we have to find the separate areas for the 3D shapes, then we can combine that areas. So we get the total surface area of the combination of solid.